Hello, Professor Alves here. This is going to be concept 2 for lesson 2, topic 2 and 162. We're going to be talking about access lists and how we deploy them. Now, this is based off my old slides, and I did a little bit of rearranging, but we're going to be more practical hands-on. I'm going to be using GNS3 to demonstrate access lists in action as compared to actually just drawing on a diagram like I would in the past. So anyway, we'll get moving here. All right, so how do we apply? We built an access list. In the previous concept, we talked about how to build an access list. Well, how do we apply it? Well, you have to go into an interface, go into interface mode. Let's get my laser pointer out. You're going to go into actual interface, and you're going to apply it. You do it with the command IP access group. In this case, we have named access list ex2. All right, short for example 2, and then out. Oh wait, what's out mean? Okay, so to add to further confusion, yes, we're using wildcards. Yes, we have a source IP, a destination IP. We have all kinds of interesting information. Another concept we need to work on is you can apply it to the out or the inbound, outbound or inbound of an interface. Ingress or egress, in or out. This adds a lot of confusion, and I have a hard time when I'm doing access lists to picture it all in my head. Back in the good old days, I would sit there at my desk and put on headphones and try to drown out the rest of the world and picture the access list in my head. Okay, because what ends up happening is the source and the destination get flipped. All right, we'll let me get to the diagram and we'll talk about that, because one other thing I want to mention is remarks. Okay, this is for folks that took programming. It was hammered into your heads how important documentation is, especially if someone else is picking up the pieces behind you. And the same is true when it comes to access lists. Try to tell us what the access list is supposed to do, as compared to commenting on each line, right? Allowing admin to ping the 192.168.1.0 network, right? So permit ICMP host. So admin must be 172. That's the source, right? Because I don't know, based on when I'm in the access list, I don't know if it's in and out. So it's very important for me to know what the access list is supposed to do, less so what it, just regurgitating what it here is, allowing ping. Well, allowing ping from where to where? What's going on, right? So that way I can know if there's a problem with the access list. All right, let's get back to that whole in and out thing. I do have this, and let's do the in and out thing right now, because I do not want to leave it. I do have a pen here. Okay. I'm not going to go and take full advantage and actually write up access lists for this example right here. That's what I used to do, but we'll go in GNS3 and actually see them in action. I think that's a better demonstration. But let's pick on interface gigabit 01 here. It has an IP address of 192.168.255.254/24. So that would be this whole network here. Yep, it's just nice and simple. There's no trunk here, okay? And let's just say, and clearly these are all servers. So let's say we want to block access to these web servers, okay? Block access other than what they're supposed to do. All right. So what we would do, and this is the important thing about in and out, we'd create the access list where essentially, permit. Again, this is where we kind of have to figure it out. What are we going to do? So in and out, the best way to think about in and out is, some people say a man in the router, right? There's a observer in the router, and think of it from the perspective of the router, right? Outbound traffic goes that way, inbound traffic goes that way, okay? So if we were to, we wanted to block access to this web server, every port but port 80, apparently it just says web. Let's be modern, say 443. So it's secure web server. So we want to block every port but 443 from our business office users, right? we would put something along the line of IP access list, and let's use a number just for giggles, 101. Permit. I'm thinking real quick in my head. I'm trying to do this in my head as I go. Permit, and because it's going to be this way, right? This will be the destination, and this will be the source. If it was the opposite way coming back, this would be the destination, and this would be the source. That's why it always gets flipped. So in this case, source. Permit. It's permit TCP 172.16.200.0 space 0.0.0.255 wild mask. I got a text tool here too. Do I have a text tool? I don't. All right. So then the destination would be host 192.168.255. We'll talk about host in a sec. 255.1.443, right? And then I would put a deny after that because of that permit. So I put the permit first because remember, like we talked about before, it's sequential in processing. So it's going to process the permit first, and then if it goes to any other port, if these users try to ping it or try to SSH into it, it's then going to block that traffic. So I would put, then after that, I would put the access list 101, deny IP source 172.16.200.0 space 0.0.0.255 space 192.168 or host 192.168. I could, instead of using host, I can do 192.168.255.1 0.0.0.0. So it has to match exactly. Every bit has to be exactly the same. So 0.0.0.0. That's it. And so what I'm doing then is the same, block everything else. Allow 443 traffic, but everything else gets blocked. We'll take a look at that in a bit when we go back to our example. Let me clear my drawing here. That's right, I already saw. And we'll go back to... All right, we'll go back to this concept right here. Again, we're going to come back to actual practical demonstration of how it looks. But I do want to kind of get some best practices here. So again, whatever works. In other words, you test everything. When it comes to access lists, you fully test because it is kind of so conceptual. Just to throw down an access list real quick without testing, it's really tough. Make sure you test it. You have a test environment. You test it well. Okay. Some guidelines to keep in mind. Best practices. Standard access lists work better closer to the destination, obviously, because because it only has source as a thing you can apply. What you do is, let's go back to this picture. If we wanted to just see that, in a way, I kind of used that wrong there. It's considered better. So if I wanted to block that, and I wanted to allow web access. So standard access lists are pretty much like, say we want research users to go nowhere near our email server or FTP server. We could put it on this interface and simply block that traffic, right? We say, deny. And again, because standard access lists do not look for specifics, we would just say deny this subnet, right? This entire subnet of 172.16.2. Well, it's 172.255. .0, 0.0.0.255, right? Block that entire subnet from coming down this interface, right? We could do that, and that's where it makes sense to use standard access lists as compared to extended access lists. Work better closer to the source. So in this example, I could go here and on this inbound, okay, because it's coming into the router. On the inbound, apply that, but again, I have to go this source and that destination, right? Because it'd be inbound as compared to outbound, which would have been there. So the source, outbound, inbound. Again, this is really tough to kind of picture in one's head, and this is why you have to test everything. Yeah, that would be the same inbound, because that'd be the source, and that'd be and that's what I would test, would be that destination, as compared to outbound. There, yeah. So that on the return traffic, I can also match it on the return traffic if I did the outbound, but inbound it would still be this source. It's just something's catching wrong in my head that wouldn't work, but as I keep thinking about it, it would work. I would apply that same access list I just talked about here on the inbound interface here, because the destination would still be these servers, right? And I can protect those servers. Also of note, I can't, let's just do the laser pointer. I can't put an access list really on the internet. The access lists do not do a good job of the internet, because if you think about it, how do I can go ahead and block certain websites I don't want to get to, but I can't do what a firewall does, where essentially I allow traffic needs to be able to come back to this. So I can't go on to this interface and let's just say outbound traffic. Again, all right, let's do it right. Let's do the extended access list close to the source. I can't put an access list on this inbound from the internet and say, hey, if you're going to block all traffic from the internet, then I'm killing the internet. I can do that, but there's no way and just allow these few websites, right? I could do that, but then it's a lot of editing. It's really difficult. So access lists do not make up for firewalls. They will not do what a firewall does, which essentially has that algorithm that allows traffic back and forth, right? All right, so standard access lists work closer to the destination. Extended access lists work better closer to the source. You need to document what you're trying to do. If you try to regulate the behavior of the whole network, then you might want to be close to the source network and use an extended at the egress. Again, outbound. If you simply want to only certain IPs be able to access a server, then you should use a standard at the closest to the interface, right? So if we only wanted this one user to be able to, which is 250, no, that's him. So, yeah, let's say they have an IP address of 1, so it's 172.16.1. Oh, I see. These are two different interfaces. Sorry, I didn't familiarize myself with this diagram before I started. But let's say if we want to just allow this one IP address, we'll say this person has a 172.16.200.1. We can put that standard access list and say permit that, and then block everyone else into whatever server we want. But we also have to keep in mind there's other servers here too, right? So we're going to have to add that to the access list. We have to look at it as a whole. All right, let's get into some practicum. So the GNS3 setup I have is right here. We have user PC1. We have user PC2. They're both on switches. They're on different VLANs. I'll show you that in a second. We'll look at the router configuration real quick just to familiarize ourselves. This is the same set. Well, I took away the Ether channel port I had before, just for ease of concepts and simplicity. So if we go into that switch and I do a quick show VLAN, we'll see that port 30 is on 4 and 20 is on 3. And this is on 23 and 33 are on different VLANs, VLAN 3 and VLAN 4. And if we look at the router, do a show run, we'll look at the sub-interfaces. We'll see that 3 has an IP address of 10.3.3. 4's got 10.4.4. All right, and they both have networking, and I set up the machines. I'm using the desktops. We're going to have user PC2 is going to be baby blue, and we're going to have, I guess in celebration of Easter, perhaps, I don't know. We're going to have a peep yellow here. I went ahead and made sure these things can ping the internet, so they have full connectivity, and we're going to just play around with it right now. Okay, so let's create an access list. And again, this would be in the router. Let's go ahead and take a look and plan out what we want to do. So it's best that we envision it. And to be honest, going into this, I haven't really thought about it. Let's say we wanted, well, let's use a standard access list, right? Let's make it so the router can ping user PC1, but user PC2 cannot ping it. All right, so we're going to limit what can ping user PC1. If we're going to do that, what we want to do is make a standard access list. Let's do it. We'll do the simple way. Config T. We're going to do access lists. I think we're using access list 1. If I'm not making, let me do real quick and do show access list. See what access lists already are on this router. I'm on the switch. Excuse me. Router was yellow. Sorry. All right. Well, good thing I double check things. Do show access. I don't need to do. I'm in enable mode. Show access lists. There we go. And it's 10. So 10 is in use. All right. Good to check before I do anything else. Config T. Let's do access lists. Tempted to do 1. Let's just do 3. Access list 3. We're going to permit. And the router has an IP address. I'm on it. It was right here. We want to be able to ping from, well, let's do something crazy. Well, no. So let's go ahead and ping. I can reverse it, but I don't, I had some thoughts, but anyway, that's more experimental type stuff. All right. So what we're going to do is we're going to permit, again, the keyword host. I meant to say that in our instruction. Remember, the keyword host is simply saying it's going to be one address. You can also do that by just saying let's do it, and we'll do the interface, the router's interface for 10.1.1.5. So if I want to put, so we're going to remember this is only going to have the source. So 10.1.1.254, and we're going to match the whole thing. So we're going to go 0.0.0.0. Okay. And so again, this is kind of confusing because I know when we set up our routes, we use quad zeros to say everything. Well, in this case, it means a specific IP because it gets flipped. Wildcard. I can log the matches, but I'm not going to do that. So we'll do that. Okay. Now, remember, if I do a do show access list 3, it's going to show me that command. Remember, there's an implicit deny any at the end. Now, what would happen is, let's apply it. Let's apply it and we'll see what happens. So we're going to go config T, or int, and I got to apply it close to the interface, and where this is on VLAN 3. Is that why I gave it a 3? Hopefully, yeah. So I'm going to go int Ethernet. Oh boy, I can't keep it all straight in my head. Ethernet 03.3 or 0.0.3, and I'm going to do IP access. It'd be nice if I spell access correctly. Access group 3. And because we're doing it close and we want the source, we're going to go out, right? Because we want the traffic as it leaves the router. Here's the router. We want the traffic as it leaves the router. It's a little bit more difficult to picture it in your head when you have a trunked port like we have here, but we'll get through it. Because we're interested in the source. So we want the out. If we did in, that'd be the destination. So we want out from the router. Okay. And now, if I do that, if I do a ping the IP address of the yellow, which I didn't do, IPA, to confirm, 10.3.3. Oh, it's 10.4. Why is it got a 10.4? I thought you were on, unless I could reverse the two. Is that what happened? Yeah, he's on 3. So user PC 2 is on 3. Did I? Okay, it's just on the lower one. Sorry. So yeah, user PC 2 is on VLAN 3, and user PC 1 is on VLAN 4. All right. So this is what we're interested in. All right. So we want to ping 10.3.3.11, and I'm guessing this will work. No, I don't want that. I want this. If I ping 10.3.3.11, I can ping it. I should be able to ping it back. So we're going to go ping 10. Oh, by the way, the router by default will use the it'll use the closest interface. That's right. So I got to do source 10. It was 1.1.254. So you always got to be careful of the router and make sure you use the right interfaces, because by default it'll use the closest interface. So when I did ping, what that did was it used the closest interface it had, which is 3.3.254, which would work because it's not going through an access list. All right. Because you're not, it's a direct layer 2 link essentially. It's not getting processed higher up on the router. Okay, but if I did like a source of, as case in point, 2.2, it does work. Why does it work? Okay, so the access list did not get applied. Show. Okay, so this is why we have to check. Good thing I always check. Access list 3. And you see there are matches. There should have been a hit on that. Unless, show run. Just make sure that got applied. Because that's 3. IP access group out. It should, and even if it doesn't hit, why wouldn't it? There should be an implicit deny at the end of it. So something interesting is going on. Yeah. Because I would expect. Okay, so it's blocking this traffic. It's working in that regard. The default is getting hit because it's hitting that interface. I think the router's a bad example here because routers pinging aren't great. Do I have a? No, I don't. Let's put. But if I went from the other, this would not work. So if I go ahead and try to ping 10.1 or not 3.3.11, packet filtered. So I actually get notification that the router's blocking it. So what's going on is the router, because the way, but usually if you specify a source, it has to get routed. I'm surprised these are working. 4.4, but that's able to ping. Let's try. I'm really crazy. 192.168, 122. Whatever my IP is for that. Yeah. What's my interface there? Show DHCP. Anyway, I'm going down rabbit holes. So let us actually do this. I'm going to go ahead and shut these down. Actually, I'm going to stop and put these on the matching VLANs. Oh, I'm going to lose my settings though. I spent all that time setting the color. Let me set this up and I'll jump back in. So there's going to be a bit of a jump cut. So I'll go full screen. There's going to be a bit of a jump cut here as I set this up. Give me a second. Okay, I've rearranged things. Let's go back and take a look. And so now you'll see I have user PC 1, which is on VLAN 1, user PC 2, which is on VLAN 2. Color for VLAN 2 is red. So there it is right there. And you can see IPA. It's 10.2.2.1. For the undocumented color, I did. I have to look for the color. I can't remember. Blue. Oh, green. I did green. So you see this will be 10.1.1. I had forgotten I'd set those up Ether channel, those ports, so I had to configure those back. But actually, I just do an IPA. And I've tested connectivity with all these devices. They now have internet, so we can go ahead and play around the access list. But let's do an IPA. As you see, I'm 10.1.1.1 here. And then yellow is, no, it's blue. Blue is next. That's VLAN 3. So if I do an IPA, you'll see 10.3.3.12 because it got a new IP address. And finally, yellow is on VLAN 4. So if I do an IPA, you'll see 10.4.4. Oh, I do IPA 10.4.4.2. All right. That's just how the pools were set up. It's fine. Everything seems to be working. Did I check connectivity with 4? I did, and it works. Okay, great. All right. So, point is, I have these color coded to what VLAN they're on, so we can kind of keep all. We can test. All right. Now let's get back to my router, which is yellow. And let's go ahead and re-look at what we did as far as that allow and IP access 3. So I'll do a show access list. I can do access lists, and I get both. I can do access list 3, where it just shows me that. So it permitted 10.1.1, and it is currently applied to show run, include interface, include also access group. All right, I can see that right there. IP access group 3 is applied to 3. So on VLAN 3, so let's go ahead and give that a try now that things are set up properly. And if I go to, well, it really isn't because there's a deny any. So it's like it's not being applied because if that was the case, well, so what should happen is here I'm on green again. Let me do I'm on 1. So if I go ahead and ping, because again IP, let's show it. Only 254 should be allowed to ping it. So if I do ping, did I get the thing reversed? 10 dots. 3.3. I think I'm up to 12. It's not working. Okay, great. But interestingly, so can anyone? So actually, let's go ahead and edit that access list real quick. Watch this. So I'm gonna get that ping going again, and I'm gonna go ahead and config T. And again, this is kind of like the ultimate nerdiness of IP is I get to play with things and real action and see what the router sees and try to understand what the router is doing. So if I do no access list 3, all of a sudden I can ping. That makes sense. So now if I instead do access list 3 and change this to be any IP starting with 10.1.1, so I'll do 255, and sometimes you have to stop the IP or stop the ping and try it again. It still works. Okay, so now we're not getting hits. Maybe do I have to reapply it? That's weird. I don't think so. It's still applied. There it is. Did I mess something up on the access list? Oh, because it's it's a permit, but it's show access list 3. It's a permit. It says it has 11 hits, 10.1.1 with 0, 0, 0, 255. It said it has 11 matches. That's weird. This should not be applied to it. 12 matches, so it's matching it. Why is it matching it? I'm doing that right. If I go ahead and do a, well, if it's getting a hit on that, Why would it get a hit on this? Permits. Because it should get a hit with 2. Because I'm green. That makes sense. Okay, because that's my IP address. So it is working as intended. So if I go ahead and ping it, I get hits. Again, you gotta be careful and do show access list. That's fine. I'll do both. As you see, I'm getting hits on it now, and that's because this is what I completely forgot was this is .1, right? So it would be why was it getting hits? Because it makes sense. That's how it was written. It was supposed to get hits. But if I go to, for example, that's them. So let's go to yellow. So this is on the VLAN 4, and if I do a ping of 10.3.3.12, I'm getting packet filtered. All right, it's going to block me. Okay. So, and that's because again the implicit deny any at the end of it. All right, let's just for giggles, we'll test this one. We want the red. And again, I'm on VLAN 2, so if I go ahead and do a ping 10.3.3.12, it's going to fail. Okay. Again, that works. There you go, as a basic access list. You're like, well, that was a lot of work for that. And again, that's kind of what I was talking about with access lists. There is a lot of playing with it, trying to figure it out. I want to get the router up. Trying to figure out what works and what doesn't work. So let's now that was a kind of a bumbling success. Let's now go ahead and remove that. So I'm going to go into config mode. It was on Ethernet's. I'll just do show run. We'll just do show run. Get to it. Right, and so we'll take this out and interface 0.0.3. So int Ethernet 0.0.3, and we'll do no and paste that in. All right, so we took that out. Now all of a sudden everyone can ping. Fantastic, that's great. All right, let's have a little bit more fun. Let's use a complex and extended access list to allow one workstation. Oh, I did want to do that real quick. Sorry, I was going to demonstrate something, so we'll do it real quick. Let's turn that IP access group out again, and all of a sudden that's going to start dropping. Linux doesn't do it, but this one still works because it is allowed to work. But if we go to 3, that was one thing I was supposed to do. Here's 3, and I go out and I try to ping something. Let's just ping 10.1.1. Let's ping this fellow back. Your 10.1.1.1. I had to statically put it in because we don't have a thing for it. That does work, but if I go here, by the way, that was failing. Again, Linux just doesn't show the failures. Sometimes it shows me packet filtered. But if I go ahead and try to ping 4.4.4.2, ping, it's going to fail, and more alarmingly, I can't ping the internet either. As a matter of fact, I don't have internet. I can't resolve either. And again, it's because of this access list, right? What's going on? Well, it's common sense that because I put a filter on this interface right here, this interface right here, Ethernet 3.0.0.3. When all these other workstations are trying to ping user PC3, they bump into that outbound interface and they are blocked. Fantastic. Well, how come PC3 can't ping? Well, think about the process, right? I go to, let's say, 2. I go ahead and try to ping 10.2.2. Whatever this IP address is, .11. it gets there. Actually, if I set up a filter real quick, or a Wireshark, a sniffer right here, we would see the traffic actually gets to user PC2. On the return, though, it's going to go through down the router on a stick, come back on that interface, and because there's that access list that allows only traffic from user PC1, it's going to block it. And when user PC goes to anywhere else in the entire world, same thing happens. It goes out to the internet, tries to ping 1.1.1. If we look to put a sniffer out on this interface, we would actually see that traffic gets routed as normal, gets NAT translated and everything, and it goes out to the internet and actually hits 1.1.1. It comes back just to die at that interface again, because its source IP does not start with a 10.1.1, right? So that's one of the problems that you run into, especially with standard access lists, is often you use them with denies. The proper way to use a standard access list traditionally, again, there's lots of different ways to do different things, but traditionally what you're going to do is set up a permit basis. What you're going to say is, you're going to set up denies. You're going to say, hey, listen, let's say I don't want anyone else to ping it, but I do still want internet. Let's set that up right now. I'm sorry for eating up all your time here, and I know if you have it, access list, then by all means you don't have to watch this. But I'm trying to illustrate how this kind of works. So let's go ahead and edit IP access list 3. So I'm going to do no access list 3. And then the way this would be set up, if I want to deny all the other user PCs to ping my workstation, but I want my workstation to still have internet, for example, what I would have to do is set up a bunch of denies. So I would do a deny, and I want to change to .2, right? And again, what I should be doing is putting remarks in here as well. I think in the simulator, it might not like remarks, with standard access lists. You can do it in the real world. You can't do it here for some reason. So this is going to be on 3, so 4.4. Okay, so I'm denying those two, and then I'm going to do an access permit any. Okay. And when that's all said and done, now what I've done, and because it's already still applied, so I'll do show access list 3. You can see I've deny, right? And then I permit any at the end of that. So a lot of times we'll say permit any. And if I exits, make sure it's still applied to that interface. There it is. It's still applied to 0.3. So what should happen now is 2 and 4 will be blocked. So 1 should still be able to ping 10.3.3 to 3. So let's go to 1, and we're going to ping our 10.3.12, and I can still ping it. And I'll be seeing hits, by the way. This is always important. I show access lists 3, and I see the 2 hits on the permit. Okay. But if I go, that is 12, right? Yeah, that is 3. So if I go here, which is 4, I'm getting blocked, right? And let's go ahead and we see if we see that hit. We do. Okay. And if we go to 2, which is red, and we try to ping it, we're going to get blocked. And if we go back again to that access list and we do show, we're going to see the hits there as well. All right. Now, the $1 million question, if we go to 3, which is blue, and I can ping the internet, it works, right? Because again, that permit any, and now we'll go back and we'll take a look at the hits. We're going to see a bunch of hits now in the any. What's going on is whatever my return traffic from 1.1.1 is not 10. It doesn't start with 10.2.2, doesn't start with 10.4.4. So it goes through, and there's a permit at the end. That's the proper way to use a standard access list. Okay, so let's go ahead and go into that interface and get rid of that access group. Did I miss it? Maybe went too far back. No access. All right, whatever. I'll just do it. No access group. No IP. Forgot the word IP. access. I'm out of practice here. No IPX, that's 3, and that was out. Okay, very good. So let's now build a extended access list, and we're going to do this one named. So we're going to go config t. We're going to do IP extended. Oop, IP access list. Yeah, that's it. That's the proper term. Extended or extend. Yep. All right. And we're gonna give it a name. We can still give it a number here, but we're gonna give it a name. And we're gonna just do demo AC, or ACL. Okay, access list. All right. And then we hit enter. And you notice now network access list, right? So what we're going to do is start putting commands in. So we're going to 10 again. So let's do something a little bit more complex. Let's build an access list where 10.3.3.12, since I know it, can ping the 10 network, but it will not. Sorry, not hit my microphone. Sorry for the extra noise there. But it can't be pinged back. So what we're going to do is we're going to say 10 permit. Let me we can do this. Permits ICMP, because again we got sub protocols, and again we're gonna do source. All right, I10 dot 3.3. We're going to do the whole network, so we'll do 10, and then we're going to do the wildcard, so 0.0.255. Let's do something again. Let's just say we want to do it because I'm doing .12. I'm testing with .12. Again, I want to highlight wildcard bits, so let's just say we want to do, for whatever reason, the first, let's say, 8 addresses, right? So I had to do something difficult math. So it's going to be essentially, well, it's going to be .7 is what it's going to be. So it would be 8, which is 1, 2, 4, and 8. So that's 4 bits. So that'd be a /28. /28 is going to be 120. I got to do this hard way, even though I know the answer is going to be 7. Such is life. 128, 64, that's 192, plus 32 is 224, plus 16 is 240. So it's actually 6, so 224. So I thought it'd be 7. That's, am I 1, 2, 4? Or do not do the 2, right? Yeah, it's, well, yeah, you need the 1. So I said I want the first 8. And so it would be, I'm just double checking my math here. 128, 164, 0 dots. Yeah. So let me demonstrate real quick here using Notepad. So again, I just want to do the first 8. So that, again, that'd be 128, 64. 32, 16, 8, 4, 2, 1. All right. So if I only want the first 8. That means the slash would be right here. So that's going to be either /28, or the way we would write that down with standard subnet mask would be 255. 255.240. And so to find out the wildcard, you can just subtract it. If you subtract it, 255 minus 240 is 15, which makes sense because if you think about it in reverse, 1 plus 2 is 3, plus 4 is 7, plus 8 is 15. So that'll be .15. So that's going to pick up that. Destination, I'm trying to think when I'm permitting it, so we want it to go anywhere. And we're going to any. All right, so that's all we want. Well, actually, okay, so we can actually specify. So what we can do is any, well, I think we can do that. And then what we'll do is for line 20, and I meant to put, actually, let's see if I can do a remark after the fact. Again, the simulator is a little weird with remarks. You can do this in the real world. Remark. I'm trying to be good and put in remarks. Allow pings from VLAN 3, but block requests. Yeah, didn't like my remark. And pings is not spelled correctly. And put it right on that. I think I could just do, I think you can't put a line number. Yeah, so it's going to be kind of right in the middle. Oh, well. I didn't do that. I should have done that first. All right, so let's go line 20, though. And whoops, I did the same thing. I don't want to do that. I know that. All right, but let's keep the 20. We're going to deny. Now we have to be careful here because we do want to allow a subset of ICM traffic because we want the replies back. So we're going to deny ICMP, but the source is, oh, that's going to be, all right, so source, because we want, deny. So I got a couple of different ways I can do this. But what I'm going to do is keep it similar. So I'm going to deny ICMP. Change that to deny ICMP. But this time, oh, but then I'll get hits on that. Yeah, all right. I was going to put a deny on the echo, because what I can do is the echo, there's echo requests and echo replies. Okay, and that's what we're essentially doing. All right, the echo is the request, right? And so what I need to do is, all right, so what I need to do is permit, I want to do that deny. I want to go back to deny echo replies. Okay, and then I'm not going to get instant feedback right now because, so we're going to do no on the 10. And I need to edit that. So I'm going to no on the 10. And I'm going to change that to permit ICMP echo. So what I just said, and I'll do a do show access list. This is where naming, I'm not in love with it because I rather remember a number than a name. What did I call this thing? Example ACL demo ACL. Do show. All right. So what this is saying is we're going to permit 10.3.3 to send out echo requests to anywhere. Okay, source, destination. In this case, too, we're also saying we're going to deny ICMP echo reply. So if anyone else says, hey, send me an echo reply, it will. My machine will, but it's going to get blocked. All right. Again, this isn't ideal because this is going to be inbound extended access list at port interface 3. So it's kind of limiting. I'm limiting what the power of the extended access list by doing something this simple. Oh, and there's a implicit. So we got to do the one more thing. We got to do 30. We'll do 100. Permit IP any. Oop, nay. Any. All right. So now that we've done that, and I'll show access lists demo ACL. Okay, there we go. There's our access list, and it didn't keep the remark, did it? Yeah. Took the command, but it didn't show the remark. Again, this, for whatever reason, the simulator really doesn't like remarks on our access list. In the real world, you would be able to just go in and edit that access list and actually give it a line number to put remarks in. wherever you want in the line number. Okay, so let us now go into interface. Again, we'll do the same interface for simplicity's sake. That's how I designed it. And this is going to be into the router, right? Because I'm worried about the sources. I'm looking at the source. So I want to see that traffic coming in from 3 into this interface. Okay. So I'm going to do IP access group. Again, demo ACL, and we're going to do inbound. Okay, let's see what happens. So here's 10.3.3. I should be able to ping anywhere in the world. That's a good start. Let's have even more fun. Let's ping 10.1.1.1. I can ping 10.1.1. Let's go to 10.1. Oh, yeah. No. Right? Who's this? Brings up work. All right, so this should not be able to ping it. 10.3.3.12. I can't ping it. Great. Because wait, this was 3, right? Who's this? This is 1. Okay, great. So then I was able to get pinged from. That's right. Because who's 3 then? This is 4. 3 was blue? Yeah, that would make sense. You're still pinging. There you go. There's 3. So you can still ping, and you can still ping 10.1.1.1. That makes more sense. I mean, it's fine. And again, this is just this IP died, but I can no longer ping 10.3.3.12. More importantly, even though 10.3.3 can ping me, that's 10.3. I can ping 10.1.1.1 if I go to 10.1.1.1, which is this one. Oh, that's 10.4. Sorry, green. That's right. That color scheme really lost me. I cannot ping 10.3.3.12, right? Because this access list is built currently, and it's not a really well-functioning access list. Again, because I'm using extended close to the source, this is not built well for the future. But again, we just have 4 IP. There's no servers in here or anything like that. So if I do a show access list, I could just access list. My fingers are not working. Demo ACL. You'll see all the matches that's going on. Oh, because they're IP NENs. So if I did something else like a wget, I'd get a hit on that. Let's get a hit on the IP NEN. I got wget on here. HTTP colon. All right, we'll do this. 1.1.1. Although, to be honest, oh well, you know what? I'll just do a simple name request. 1.1.1.1. Ooh, what happened there? Sometimes it does that. That's weird. It likes IPs though, right? Alright. It was working earlier. Oh, that's the PC. That's interesting. What if I go ahead and do that wget? Interesting. But I should see hits on the firewall because it went out. Let's do yeah, it did permit it through. There's just something kind of funky going on right now. Anyway. All right. I mean, if that was a constant, let me go see. I'm wondering if that's the Bash browser. Let me see if I actually go to workstation 3 and open up the actual thing. Let's try to go like the. Yeah. Okay. It is actually going out to the internet. I have full internet. It's just there's something going on with the console. Excuse me. All right. So that's probably not the most elegant display of access list, but hopefully by me applying it in different ways. Again, the in-out thing is important because you have to keep in mind what's source and what's destination, and picture that traffic, especially when you have extended access lists, because those not only do you not have IPs that get flip-flopped, but also the port numbers. And remember, you have dynamic port numbers that go out, so it's not going to be predictable or static. Or, the PC will use a dynamic port number as the source port when it goes out to port 443 or something along those lines. So again, planning this out, living by those general rules does make sense. It does make your life a lot easier. All right. Hopefully I didn't find this entirely too confusing. And I think I just want to make sure I got all my notes. I know this was kind of an awkward one. But got that. All right. So there's just one more concept video in this. We're going to talk about iOS privilege levels and username and password, which we already used. Anyway, we'll look for me in concept 3. Otherwise, I hope you have a good day. Bye.